What is scientific notation? Scientific notation is generally used to express very large or very small numbers easily with the correct number of significant figures. And when it comes to the metric system, scientific notation makes things very easy because metric system is based on the power of 10, and in the scientific notation we are going to utilize that power of 10. So for example, here is a number 4300, and let's say it's some kind of measurement, and these two zeros are not significant. Well, by looking at this we already know that they should not be significant, and so there are two significant figures, but we can make things even more clear by writing it in scientific notation. In the scientific notation, we have two parts. If you look at the right here, which is the correct scientific notation for this number, we have 4.3 times 10 raised to some exponent. 10 is the base and this is the exponent 3. This here 4.3 is called a coefficient. The coefficient must be greater than equal to 1 and less than 10. So it can start with 1 and go all the way to 9.999, as many nines as needed according to the significant figures. And in the coefficient you show all the significant figures. So if these two are the only significant figures, then the number here would be 4.3, and then times 10 to the 3 represents the 1000, because it should when multiplied together we get the 1000. How would you figure out that this number up here, the exponent, should be 3? Well, in the normal decimal notation, which is what we call this as, where is the decimal point? We are not showing it, but where is it? It's right here after this 0. And how many decimal points are we moving to the left? We are moving 1, 2, 3. We are going between 4 and 3. So we are moving 3 decimal places to the left, and so this is a 3. Whenever you move to the left in your writing your scientific notation, the value of the exponent is positive value, a positive number. But I like to remember it in a different way. I like to think of it this way. If my coefficient becomes smaller than the original number, then my exponent will be positive. I have to make it larger. Okay, so here we have 4300 and my coefficient is 4.3, which is smaller than 4300, hence my exponent is 3. Now what if this 0 was significant and this 0 was not significant? Could you represent this number in the decimal notation? The answer is no. How would you specify this 0 as significant and this as not? If you put the decimal point between these two, that would turn both of these as significant. If you remove one 0, you are basically chopping off the value of this by 10 folds. Only way to do that is by expressing this number in scientific notation. And what do you think would be the coefficient? The coefficient would be 4.30 times 10 to the 3. So you can see how scientific notation makes it possible to express your values with the correct number of significant figures, apart from being able to express large or small values. Here we expressed a large value. Let's see an example of expression of smaller value, and this is what we just talked about. Before we look at the smaller value expression of using scientific notation, if this 0 was significant, here we are showing it as 6.20 times 10 to the 3. But if the zeros are not significant, you show it as 6.2 times 10 to the 3. What if both the zeros are significant? We might as well place a decimal point here, and if we wanted to convert that to scientific notation, it would be 6.200 times 10 to the 3. So here we have this number, a small number, and when I am converting it to scientific notation, I am converting my original number to this coefficient between 1 and 10. So the original number here is less than 1, and since my coefficient can be only greater than equal to 1, less than 10, it must be 6.2. Because I am converting this to a larger number, my exponent here will be a negative value, and I am moving to the right. So how many digits, how many decimal places am I moving? 1, 2, 3. Hence this is 6.2 times 10 to the negative 3. That's how we get our scientific notation. Here is a number you will encounter later. Uh, Another number, not this one exactly, but something that's so small. But imagine how tedious it would be to have to write this down over and over again whenever you are referring to it. Instead, we use the scientific notation to express this number. And you would see that the four sig figs are shown here, which show up here as coefficient 6.692 times 10 to the negative 24, because we are moving 24 places to the right. Here are a bunch of problems. Please express this in scientific notation. Pause the video and think about it, or write your answers down, and I will mention how each one has what correct scientific notation. Here your coefficient should be 1.8 times 10 to the negative 4. Here your coefficient should be 3.004 times 10 to the three. How about here? Your coefficient should be 3.00 times 10 to the 2, and here it should be 3.04 times 10 to the negative 3.